I have built plenty of these ZVS drivers before, and because I haven't had these perf boards before, I have usually just screwed the MOSFETs to the heatsink and built everything on midair. When I was looking at my soldering box, I saw the perf board and I realized that it would be a far better idea to build a circuit on it. So as you can see, I built the circuit on this perf board. There is a lot of hookup wire on the back side of the BCP, the perf board as well. The main components are these switching MOSFETs, their pull-down resistors, gate protecting Zener diodes, and these fast switching diodes. There is also a bank of capacitors, a coil, and the resistors for the gates. Also, in addition, there is a relay, a N-channel MOSFET for driving the relay, and octocoupler for driving the N-channel MOSFET. There is a minus input, plus input, a pin for triggering the relay, a plus for the flyback coil, and two minuses for the flyback coil. I think this is pretty simple. You just unscrew these terminals. The next thing we are going to connect is wire for the triggering, because there needs to be 5 volts on the trigger to turn the relay through the octocoupler and this N-channel MOSFET. I have chosen 5 volts so it can be triggered by Arduino, because I'm going to be using this thing to charge capacitors on my upcoming coil gun. I'm going to be powering this ZVS driver with this 18 volt battery. I'm going to put a clamp meter to the mix so we can see how much current it's pulling. So set it to DC amps and zero it out. So as you can see, it's pulling no current even though these power wires are connected and there is nothing on the output because the relay is not on. So now everything is connected and we can trigger the relay with this wire. There is 5 volts coming from it. And my computer's monitor didn't like that. It just turned off. So I guess that we should get these things a little bit away from it. So let's try again. Pretty nice arcs. The MOSFETs are warm, but they are not really that hot. The capacitors are not hot either, or the coil. So that's it.